Assalamualaikum and good day. So now we will look at 5.4 surface area. When the arc of a curve is revolved about a line, it generates a surface. A surface of revolution is a surface generated by rotating a two-dimensional curve about the x-axis and y-axis. The resulting surface always has azimuthal symmetry. Examples of surface revolution include cone and cylinder. Azimuthal symmetry means that when you revolve the curve, it will give you the same pattern. Okay. For example, you have a curve y equal to fx in the interval AB is revolved about the x-axis. Okay, previously when we learned about the area below the curve, okay, let's say you have this curve, and then if we calculate the area below of the curve until bounded until the x-axis, we find this area, alright? But this time, we revolve this area into the x-axis. Okay, so if we revolve into the x-axis, this area is actually we give you an object, okay, or if we give you some kind of geometry where we can calculate all the total area by using the formula of the surface area. Another example, let's say you have this curve, and then previously if we calculate this curve, okay, the area under the curve bounded by this curve until the x-axis, we just find the area here. But if we revolve this area, revolve about the y-axis, then we will have some kind of this object. Then we can calculate the total area by using the surface area formula. Okay. So another example, if you have the area given by this triangle, for example, and then if you revolve about the y-axis, then it will give you a cone. Then you can calculate the total area by using the surface area formula. Alright. Similar to this cylinder, let's say you have some kind like a square here, okay, and then you revolve about the y-axis, okay, then you will have the cylinder. Then you can find the total surface area or the total area by using the surface area formula. Okay, so in this study, we will look into two important formula, okay. So the first one, if you're revolving about the x-axis, if the function y equal to fx has a continuous first derivative throughout the interval x between a and b, then the area of the surface generated by revolving the curve about the x-axis is given by this formula. Okay, as here represent the surface area, then you get the value by evaluate the integral from a to b. 2 pi time with your fs, and then time with the formula of the arc length here. Okay, remember this is formula of the arc length, alright, respect to x. And then if you revolve in about the y-axis, if the function x equal to gy has a continuous first derivative throughout the interval y is between c and d, then the area of the surface generated by revolving the curve about the y-axis is given by this formula here, similar with previous formula. However, we change all the variable here is with respect to y, and a limit also depends on the limit of the revolving at the y-axis. Alright, let's look at this example. Find the surface area that is generated by revolving the portion of the curve y equal to x cubed between x is between 0 and 2, so about the x-axis. So if we sketch this curve here, alright, So we have y equal to x cubed, something like, something like that. Okay, but we only want the area between 0 and 2 here. We only want between 0 and 2 here. Okay, somewhere here. So we only look at this area here. So if I remove about the x-axis here, okay, so I should have something which is the same pattern here because it's a azimuthal symmetry. And then if I remove, so I should have something like this. Okay, so now we want to find all the area, okay, given by this area here, okay, where we revolve about the x-axis here. Okay, so we will use this formula. Okay, so now we should have our fx. So our fx equal to x cubed. Then we differentiate f prime x equal to 3x squared. So to find the surface area, okay, we use the formula. It's integrate from a to b, which is 0 to 2, and then 2 pi fx time with this respect to x. dx. Alright. So we simplify first before we evaluate the integral. So we have 2x cubed pi. And then if I square everything here, I should have 1 plus 9x power 4 dx. So in order to evaluate this integral, we will use the technique of integration which is integrate by substitution. Okay. So integrate by substitution, I let everything inside the radical sign here equal to u. Okay, so I differentiate du dx equal to 36x cubed. Alright, to be easy, you can see here you have 2x cubed dx. So we want to replace this also with u, means that I can have du over dx equal to 2 times with 18 x cubed dx, x cubed, okay, where I should have my 2x cubed dx equal to 1 over 18 du. Now I substitute back. So s equal to integrate from 0 to 2. Okay, so you refer here, you refer to this integration here. Okay. So I have 2x cubed dx. 2x cubed dx give me 1 over 18 du, and then I have pi here, and then square root u here. So everything here is a constant, so you bring outside. So I have pi over 18 integrate from 0 to 2 u power half du. So now I should have pi over 18 u power 3 over 2, and then divide by 3 over 2, which is 2 over 3 from 0 to 2. Okay, so simplify further. So you have 3 here, you have 2, so I can simplify this. Okay, time with a constant outside, so I should have pi over 27. And then u, I replace back my u. So what is your u? Remember, previously we let our u. So this is my u. I replace back here. Alright. So I should have 1 plus 9x power 4 power 3 over 2. And then from the limit 0 to 2 here. Okay. So s equal to pi over 7, 27. Substitute the limit. 1 plus 9 times 2 power 4, 3 over 2 minus. So we're at 0, everything is 0. So you're left with 1 only. 1 power 3 over 2 also 1. Okay. So if you simplify this, you should get pi over 27. So the term inside here will give you 17,465,0312, and then minus with 1. And then you simplify here, you should get 64.6308 pi. So this is our solution. You can either time with pi, okay, make sure you're calculating in radian, or you can keep in term of pi, no problem. Okay, so this is the total area or the surface area for this the whole area here when we revolve this curve about the x-axis here. All right. Okay, now if I share you by using Maple to give you some kind a better visualization. So if you can see here the same problem, okay, if I plot by using Maple, so this is a better sketching line compared to my free sketching. So this is our curve considering 0 to 2, okay, and then if we revolve about the x-axis by using Maple, okay, I use the surface revolution here. So if I plot, so this is actually what you will have. This is the object, what we have actually, okay. All right. So if in 3D, so I can show you. So actually if we look in 2D, this is in 2D side, okay, this is in 2D side where you have y-axis and also the x-axis here. So the red color here is the area, so we calculate this area given by this red color here by using the formula of surface area that we did previously. All right. So this is what we get if we revolve our curve y equal to x cubed about the x-axis. You should have something like this. Okay.